everyone. I'm very happy to be here speaking with you. I'm sorry this is not yet a two-way conversation, but I did take a look at the participant list, and it looks like there's a very diverse background set in the audience. So I will go through my presentations and very much look forward to the questions coming up. To go through, sorry, I'm clicking on slide one. So what we'd like to do in the next 30 to 40 minutes is discuss the evolving business models. I think everybody on the call knows that there are some very exciting changes happening in the utility business model and in the energy access space. And we're sort of breaking the old rules of formal economics where everyone thought supply always equaled demand. We know that's not true, but we'll discuss that more. We'll also look at market segmentation, and I'm hoping everyone will come away with some meaning behind the images of a bullseye, that concentric circle that you see on the slide right now, and a stair step in talking about market segmentation for energy access. I'm also hoping that people will become energy efficiency activists. We'll talk about that more, but efficiency is the finest fuel and allows us to deliver a lot more energy services with whatever energy we're delivering. And finally, we'd like to identify accompanying opportunities. And we'll learn more about that, but really looking around, lifting your heads up and seeing what's happening around the space where you're working on rural electrification to have better opportunities for your business and for the communities where you're working. So I, as Fernando said, work with EarthSpark International, and just very briefly about EarthSpark so you hear where we're coming from. We build clean energy access in Haiti, and we always say that our mission is to eradicate energy poverty. Our method is to do the research and development on business models that can spin off and scale to address specific aspects of energy poverty. And so far, we have spun off two companies. BREADFRUIT is a Haitian social enterprise incorporated in Haiti. It focuses on clean energy retail, and so it is a distribution company working on small-scale solar, efficient cook stoves, and it has a national network of over 100 retailers. We do back-end service, and we've been around since 2009. EcoPop is short for, and I should say Energy Pop is clean energy in Haitian Creole. EcoPop is short for clean community electricity in Haitian Creole. And from the very beginning, EarthSpark recognized that small-scale lanterns and efficient cook stoves are life-changing tools, but they're not the big answer. They're not the big solution. And so everyone aspires, as we all know, to enough electricity to turn a motor or to run refrigeration. So as much as we value the small-scale solar products, we are also very much focused on building infrastructure to deliver these higher quality energy services where possible. So of course that takes more infrastructure and more planning, and that's a little bit of what we're going to talk about today. But in the process of getting to, and in the slide you'll see the site of where we turned on Haiti's first prepay microgrid, which was those bigger buildings off to the right, and now the sites of many of the other customers who are now turned on for the grid expansion. Getting to EcoPop, we ran into a problem, which was we couldn't figure out how to actually build the grid we wanted to with the meters that we found on the market. So when we were building infrastructure from scratch, we wanted to build the best infrastructure that today's business models and today's technology could offer, something that would make sense and enable cost recovery for a scalable business model. And we really thought that that meant that we needed low-cost, high-functionality smart meters, something that could be prepay, something that could do demand management, something that could have modifiable tariffs. And we did a long search around the world for something that could fit our needs. And there are a lot of prepay meters out there, but none of them were to these specifications where you could buy them. We needed, at the time, just 100 of them. They all either were too big, too expensive, or came with really expensive back-end software packages that were not appropriate for our needs. So we spun off, we built some by hand. We recruited friends and volunteers, and then with the gracious generosity of those friends and volunteers, built 54 meters that worked for 2.5 years in the field. But then we were able to spin off that company so that SPARKMETER could actually commercialize that technology and get something even higher quality that we now have running for 430 customers in Les Anglais, Haiti. And the thing that enabled us to move from the 54 to 430 customers was a USAID solicitation that came out. It was called Powering Agriculture. And this is feeding into the integrated rural electrification story here, because the solicitation asked the question, how can one deliver cost-effective renewable energy to agricultural actors in developing countries? And when I first got this, I forwarded it on to my agricultural friends in Haiti because I focus on electricity. This was electricity and really agriculture. And then there was this aha moment, fortunately before the proposals were due, that was, well, wait a minute. If the question is how can you cost effectively deliver renewable energy services to agricultural actors in developing countries, the answer is what we're trying to build already, which is a town-sized solar-powered smart grid with differentiated customer classes, so different kinds of users of electricity, with different times of need and different kinds of demand, and smart meters that will enable us to shift supply to that demand and do that in a way that is cost-effective for us so that each different kind of customer class can essentially buy down the cost of the grid for everyone else. I hope everyone on the call had a chance to see this presentation. It is Elon Musk, the CEO of Tesla Motors, announcing a battery storage solution for the residential and light commercial markets in the U.S. and ultimately around the world. And he did an excellent job of talking about the grid dynamics, how supply of electricity, especially wind and solar, comes at times that is variable, and how demand for electricity does not always match that supply. And his solution that he's selling is his battery, which is clearly his business objective, but the deeper reality is that storage on this grid, coupled with smart meters and smart demand management, can really start to move demand to meet supply, so that the whole fundamental business model of the way that electricity systems are working is becoming more adept to the solar, the wind, the smoothing out of those peaks to be more cost effective. So for Les Anglais, this example is illustrated by the mill. Off on the right, you'll see the mill owned by Julio Francois in the little town of Les Anglais. It's an old mill that was bought used in the 80s, and it's diesel powered. And there are efficient electric mills on the market, and we are working with Julio to source one of these efficient electric mills. And he will be using this mill mostly when people are lining up at his mill to grind their corn, their sorghum, their rice, and their coffee. And so he will experience extreme peaks. If we were building a system just for him, then we would need to put a lot of solar or a lot of generation to have the capacity to meet his peak demand. And then when the mill is not running, then we would have that excess capacity. And if nobody else was using it, we would have just these underutilized assets. And so the mill is going to be running during harvest season and also on market days, most especially on market days during harvest season. So that means that Julio is going to be spinning his mill on Wednesdays during harvest season and using a lot of electricity then. And this is just one of many customers, but he will be an industrial load. He's quite small, but this is a small system. And the rest of the community has the option now of a television usually tariff. So we have different levels of access for different levels of service for the customers. And so some people are on just a lighting level, some people are on a television level, some people are on a freezer level, and some people are on, like Julio, he's sort of an industrial class. So he is able to meet his needs with the power that he needs. So on the community side, there's an option to use the smart meters for a television usually tariff, which means that most of the time people have the level of electricity for television, and that could be television, that could be radio. It just means that they are at the load that would enable the use of the television. And then on the days when there's constrained capacity, meaning probably Wednesdays during market days, that's when they will still have electricity, but they won't be able to turn on their TVs. And the way that that works is the meter just cuts off service for a period of 10 seconds. The person can unplug the TV or turn it off, and then the meter turns electricity service back onto the house. And just to illustrate another sort of application of agricultural productive uses of electricity, breadfruit is a crop that I'm sure many of you know. It is nutritious. It's a it's a fruit that grows on trees. It tastes sort of like a potato. It has a very short shelf life. It can rot once it comes off the tree in 2 days. And it all harvests at the same time in the region. So there's a real glut in the market, and these nutritious crops in the region literally rot on the ground under the trees for want of processing because there is not enough infrastructure to move them to market. And even if there were, it's the time when the market is very low. The market price is very low. But if you peel them, shred them, and dry them, which is what you see in this order here, then you get these crisps that can be turned into flour, and that flour can last for 6 to 12 months. So again, using electricity to sort of unlock economic potential in an area. Let me move this guy. So without electricity, we have low productivity. And the goal here is to not just bring lighting to a town, but really bring enough electricity with some other technical assistance, if helpful, like sourcing the mills or building the value chain with that woman that you just met, Enette, with her breadfruit, to make it to market and to source efficient appliances. And this really is a virtuous cycle. The grid unlocks agricultural value, and then these agricultural businesses strengthen the grid, strengthen the finances of the grid by being reliable consumers of electricity and paying for that electricity. I should say that our grid is mostly solar. It's 100 kilowatts of solar. It's about 400 kilowatts of lead-acid battery storage, and then we have a 30 kVA diesel genset. So we do have some excess capacity during the day right now. We are going to implement time of use pricing to really incentivize people to consume the electricity when it is actually least expensive for us to be generating the electricity. So getting to market segmentation here. Looking at the world of energy access as a bullseye, right in the middle we have the central grid. And the central grid is anyone that is already connected, and they may not have reliable service, but that's their source of electricity. And then we look out a little bit close to those areas in the environs or areas where there's a dense population, not too far. And there's a huge market for grid extension and infill. there are many, many people in the world living under power lines in major cities. So energy access is not just rural, energy access is also urban. And then there are also some urban areas in rural regions. The Les Anglais grid is a town-sized grid. So it's this teeny little urban space in a generally rural area. And those are really good for microgrids. You have a density of homes and consumption, and that's sort of how we're viewing the third loop out there. And sometimes if you have some sort of industry that consumes a lot of electricity and is close to some other houses, that can justify a microgrid as well that includes residential customers, even if the residential customers themselves are not sort of enough of a demand to justify the expense. It's sort of the sub-additive ability where if you serve the residential customers and the industrial load, then it's cheaper to serve both and everybody's better off. I put my battery charging and nanogrids here in brackets. It's something that I know people are working on. I think that with all of the advances in the standalone solar systems, it sometimes feels like the standalone solar systems are just running as fast as the competitive advantage of any sort of nanogrids where you have basically a very small solar system and then cords running out, or the battery charging where people would bring batteries to a charging station either in a microgrid or just a solar station or a grid, a central grid, and then carry them out to use them in the evenings or when they need electricity. So that's possible, and that would be sort of right around here, sort of outside the place where the microgrids are and outside the place, where the existing grids are. And then the standalone systems are the places where you have a large number of people living in very distributed ways, and it makes sense to serve them with standalone systems because their demand is so small that it can be more cost effectively met with standalone systems. And just like the Elon Musk keynote, I highly recommend that everyone read this World Bank SMAP paper if they haven't already, but it's defining different tiers of energy access. So before, people used to say, you know, this person has energy access or doesn't, which really doesn't leave any room for nuance, whether this person has a lot of energy, whether they have electricity but no improved cooking fuels, whether they have a central grid connection but it never turns on. So it's really a step forward in the world of sustainable energy for all to have these tiers. I would say they do recognize, the authors do recognize that there's very little space between tier 0 and tier 1, whereas, or I guess tier 1 is just very different if you have 1 watt or if you have 50 watts of energy access. That's a significant change in sort of where you are in terms of what you're able to power and what your energy services can be, especially in light of the more and more efficient end-use things coming out. So a lot of people will say grid extension is the way to electrify the world because everyone will want to sort of get that connection to the major utility. And that ignores the reality that a lot of the grids themselves are not well-performing grids, and also it's not the most cost-effective way to get high-quality energy services to people running central grid lines very far to low load centers. So just taking a look at Haiti, there are 6 different grids in Haiti, And you can see that they are pretty limited. 25% of the population has access to these grids, and the rest of the country has no access. And the state of Electricité d'Haïti, EDH, in Haiti is that they are hemorrhaging money. They do not have a viable business model, and even though their kilowatt-hour tariff is 35 US cents per kilowatt-hour, they are not meeting cost recovery, and they're just surviving through direct transfers from the Treasury of Haiti, money that could go to other things if it didn't have to keep just keeping the lights on in EDH. And so it's not the perfect solution, but are microgrids the best solution? Well, it totally depends, really, because a lot can go wrong. And I think that's what everybody needs to start talking about more, is that as much as we all like to talk about how important sustainable energy for all is, we sometimes don't talk enough about how challenging even these very well touted solutions are. So yes, microgrids are awesome, and I now have one functioning, so I can say they do work. I've seen a bunch of them, and we all know about them. It sounds like some of you also run them. But it really depends. In Haiti, the pictures behind the text here are a microgrid at the end of the peninsula, very close to where our grid is. It has a 250 kVA genset plopped down in the middle of a town, and it almost never turns on. It may turn on for 20 hours a year, and that's when a senator or some very important person will come and bring fuel and a repair personnel to try to figure out how to get the grid functioning again. And this grid is very similar to another 30 grids in Haiti and many around the world, where someone has the idea that electricity is important, and the way to solve that problem in their mind is to bring supply of electricity. And the supply of electricity is in the form of a diesel generator, and a bigger diesel generator is associated with more electricity and more prestige. And so these humongous diesel generators get dropped off in these towns, and you'll see on the right the poles and wires, the distribution system for this grid is very nice. It's very sophisticated. It's not just bamboo poles and extension cords. But it never turns on. Electricity never runs through those wires because there was not planning about consumption and a business model and cost recovery and operations when this grid got set up. So really it's important for anybody looking at sort of figuring out what should go where in rural electrification to work with a lot of stakeholders and take a lot of factors into account. You know, on the bottom here I say energy supply is less than half of the equation for integrated rural electrification. And everybody thinks, I mean, people don't really think, but many people actually equate solar panels or a diesel generator with solving energy access. And it's just very, very, very far from the truth. It takes a lot more for successful long-term rural electrification to happen. And that really requires deep planning, deep partnerships, and really on the market assessment side, it's taking account of physical and environmental properties. Is the town laid out in a way that would allow a distribution system to happen? Is there going to be flooding? What are the environmental sort of impact potentials or threats? Is there a grid there? It's physical, technical, economic, financial, social, political. And political can be regulatory, but it can also be the local politics of the place. In Haiti, the municipalities can sign over concessions to third-party grid developers. And so if the mayor wants to work with you and give you a concession, then then that's great. If he doesn't, then everything else can be a perfect fit for microgrid development, and it's a terrible town to try to build a grid in, because that's a critical component. On the technical side, I know that Homer Energy is often sort of mentioned and available in these webinars, and so I just wanted to sort of remind everybody that they're an excellent tool for figuring out generation mix. And I know there was a variety of backgrounds, so I'm sorry that most people know this already, but really getting your understanding of what your generation mix will be based on resources and costs is incredibly important. And another shout out for IRENA. I believe there's someone from IRENA on the call, but their Renewable Energy Atlas is public information on renewable energy resources around the world, and it's down to some pretty high resolutions. I used to work for 3Tier that supplies a lot of the numeric weather prediction modeling, and I know how important it is. I can also say that for microgrids, it's really important to not depend too much on sort of super detailed wind assessments, because that will blow your budget. Most of the places where a lot of us are working, it's very sunny, and the small grids that we're looking at are excellent candidates for these kind of solar systems. So anyway, I would plug Homer Energy, and I would absolutely take a look at the IRENA Renewable Energy Atlas, just to get a sense of what the resources are as you move forward. And then on the demand side, doing load assessments is an art, not a science, but you need to plan for, you need to talk to everybody and develop your methodology on what exists and what you think will exist. And the real point here, the real takeaway is do all the planning and make sure that you have a long-term plan so that you're avoiding dump and run development. We've all seen a lot of broken systems that are worse actually than having done nothing at all. So prioritize energy services, not kilowatt hours. This gentleman has a big block of ice on his head, and he is delivering the service of drink cooling to the town that's on the other side of that river. And that block of ice has been in the back of an air-conditioned, uninsulated truck in the beating sun of Haiti for the last hour and a half before he got it on his head. And now he has to walk across this river, which does get pretty deep. And he will deliver it to folks in Les Anglais. This is before the grid started working, who would chop it up and put it in their coolers. They have old refrigerators on their sides that they use as coolers to cool drinks to be able to sell and consume. A small shop, a very, very, very small shop in rural Haiti that is a drink seller will pay $60 US on some of these months to get these services of having cool drinks. So you can just imagine what the price equivalent, the cost equivalent would be if they had a refrigerator, and then it becomes very clear that $60 US would be much more than what they would be paying for those refrigeration services. And when talking about a multidisciplinary market study, I put these photos in because it's really important to look around and speak with people on different days to understand what's really going on. I know I can't take questions from the audience, but I hope you all have identified this little yellow string that's coming out of the blue barrier connected to the cell tower. And that is an extension cord, of course, and it's crossing this street and there's that street going into the community building. And there is no sign of electricity in the community building when you go in there on normal days. If you ask people if there's electricity, they'll say no. But there happens to be a soccer game going on this day, and so people are using electricity from the genset in the cell tower to consume. And of course, that's theft. It's okay. It's somebody else's problem. But it's good to note that that will happen, or that could happen if people are lax about it. And it's good to recognize where the theft is going, because there's clearly a demand there. And just to talk quickly about microgrid cross structure, when you're looking for places for microgrids, you really want these densely packed towns. If you have those densely packed consumers, then your cost to connect them is really quite low. And you can do partial cost recovery for the fixed cost for a fixed connection fee. So in Haiti, we are doing a $30 cash and $300 loan for the connection fees. I'm actually crowdsourcing that loan through kiva.org, which was a fun and interesting thing for us to be able to do. And also, I've been talking about this prepay, pay-as-you-go customer class, but there's also Julio and his mill. Ultimately, we'd like to be selling to Digicel, the telecommunications company. And so if you do get these larger customers, they're still not going to be bankable if they're local businesses for the most part, but some of them, if they're international corporations or even national corporations like the telcos, could pay for their electricity service via a power purchase agreement, which then in turn could be bankable and reduce your borrowing costs. So when I said that we were looking far and wide for these prepay meters, we found that they were actually really essential to unlocking the business model for microgrid scaling for low consumption customers. Because when utilities or microgrid developers hear about the imperative of energy access, a lot of them feel the imperative, but they're also shaking on the inside because they're terrified that if they extend service to these communities, either there will be theft or or the cost, the sheer cost of delivering energy to these communities, sending people to go collect bills, to read the meters, to interface with the customers, to get there in the first place, will just outweigh the revenues that they're receiving. So this is the activist part. I've seen televisions like this in really old trucks going to really remote places in Haiti. And this is an image I just pulled off the internet, but these are old, inefficient appliances. And there are few things sadder in the electricity space than seeing someone receive a gift like this. And so if you're doing rural electrification, it's really important to get ahead of the appliances and get ahead of the grid with your explaining what people can and cannot power, what things will cost, to make sure that something like this doesn't arrive in your grid, which is just a sad waste of money, either up front because somebody sent this to the customer and now it won't be used, or the customer actually will use it and it'll cost a fortune. So here's the activist moment. I am tweeting about energy access. I think you all know there's a Sustainable Energy for All forum in New York coming up this month. And I am tweeting right now calling for more attention in this forum. Energy efficiency is one of the 3 pillars of Sustainable Energy for All. but energy efficiency for energy access is not getting enough attention, and it's so critical to get the appliance manufacturers moving into building very deeply efficient and also ruggedized and also nice appliances. People, just because they're poor, doesn't mean that they don't want something beautiful. And the technology is absolutely available. It's like what happened to LED light bulbs should be happening to AC fans, radios, televisions, everything that people are using. And the Sustainable Energy for All Practitioner Network is working on this, but I think if the World Bank and the Department of Energy and the Energy Access Practitioner Network and SE for all heard from you guys, I think it would potentially help move in the right direction. So please retweet or treat efficiency and maybe waste less, do more, something to let these people know that the practitioners are really calling out, saying that this is important. And finally, I want to talk about accompaniment. And accompaniment means taking a look at what you're doing while you're doing energy access. And energy access is whatever it is that you're focused on. So while I'm focusing on the microgrid, I also am doing it under the EnergyPwop name. And so I also have all these very nice clean energy products that are available for the folks who are just beyond the microgrid. And that's where I really think about the bullseye again, is that some of these people are living very close. And if you're building value chains for getting your technicians out to the microgrid, then it is easier to also move this last mile distribution work out into this town, and vice versa. If you're out selling solar lights and efficient cook stoves and you find that there are really receptive people in certain towns who are really proactive and excellent partners, then that actually can pave the way for sort of the triage that needs to get done on determining which towns are good candidates for microgrids. And looking at another accompaniment, looking at fuel switching. So if you'll see, I sort of snuck this this stove from the last slide in here. I put it in the yard here. But fuel switching, making actual cooking electrified, and electrification of transportation. When I say this, it sounds crazy because there's such a constrained amount of electricity in most rural areas. However, people are paying a huge amount of money for these fuels. And so if we have excess capacity in the middle of the day from our excess solar, we could be charging electric bikes that some business owner would rent out. Or we could be powering rice cookers that do consume a lot of electricity, but if they consume it at the right time and the grid is big enough and the planning has happened well, then it can be a real opportunity. So there again, the grid unlocks productive use value, and productive businesses then strengthen the grid. So whether that's the agricultural side or the rice cooking ladies or the people with the electric transportation, the more you thoughtfully work with your customers and sort of enable these uses of electricity at the times when the electricity is most flowing, then it's this very self-strengthening circle. And then I wanted to add two more things here. Accompaniment can be good for your bottom line as a microgrid developer, but it can also really be good for the communities where you work. And so I wanted to talk about the role of agriculture and conservation. When you come into a town and unlock some agricultural value, there is a possibility that you're actually increasing the incentives to cut down more forests, to grow more of those things. And when electricity arrives in a town, it is a historic moment. And I think it's really important for grid developers and people in this space to recognize that at historic moments, changes can happen. And whether that is sort of accompanying with a value chain for whatever is getting processed that has a certification of fair trade and forest conservation to actually increase the value, but also increase the awareness of the conservation, increase the possibility that that can happen in a region. That's a huge value potentially to the local business people and obviously to the forests in the world. And the same is true for the role of women. One thing that EarthSpark has been thinking about recently is feminist electrification and recognizing that this moment when electricity arrives in a town changes the town, and trying to work thoughtfully in a way that most ensures that the outcomes for women are better post-electrification than they were before. And that goes into, again, the planning process, making sure women are in the infrastructure planning meetings, insisting on that. There have been studies saying that it just very rarely actually happens. And then workforce development. You see this woman on the right is wearing her Energy Pop t-shirt and carrying a ladder through town, and that really changes the perception of what women are good at doing when everybody sees this very capable set of local ladies out running the grid. So I'm looking forward to your questions. Business models are evolving, and that can be Elon Musk and the big grids in the United States and Europe, and it can be the small grids and the little work that, the little grids that we're building, and even the off-grid space. But it's all just a different side of the same circle. There's a great line that says netted islandable microgrids, and that's Amory Lovins who has called that sort of the future. And so in rural Haiti and a lot of the energy access contexts, we're building that from the ground up, whereas in the United States and other places, we're trying to sort of retrofit into existing infrastructure, which in many ways is harder. So we have a good opportunity to build better systems where there is no incumbent infrastructure. And then market segmentation is both a bullseye and a stair step. It's both based on your location and on your consumption. And that stair step needs to be probably a little bit more nuanced, but it's a good framework to think about. And please talk about the value of energy efficiency. That's the place where I feel EarthSpark has failed to do what it intended the most. And we went right to LED light bulbs with the arrival of the grid, but we have not sourced deeply efficient end user products for the other things that people will be using on the grid. And I would really love an international institution to do what it has done for lighting Africa and now lighting global, but for deeply efficient end user products in the sort of ruggedized AC space. There's been some progress on a DC television. They did a contest last year. So please tweet, thank you. And then accompanying opportunities can augment the bottom line and enhance social benefits. So just keeping your eyes open and looking around for who's doing what in the town and how this historic moment of the arrival of electricity can enhance the good things that are already trying to happen in the town. It's really good. So I'd love to open it up for